Today I just want to look at very interesting triangle which we will call Pascal triangle. Some of you may know about this, and if you look at this triangle you can see that it is the building of this triangle is very easy. It's like this. So I will make it precise. So you start from 1, then sideways you write 1, then if you add 1 and 1 you get 2, right, and again you write starting from 1. Now you can see that this 1 plus 2 is 3 and 1 plus 2 is 3, and you always start from 1. Again you start from 1, then you add 1 plus 3 you get 4, 3 plus 3 you get 6, and 3 plus 1 you get 4. Then so you are starting and ending with 1, and in the middle terms you can add the previous terms exactly like the middle, right. So for example, randomly if I choose a consecutive number 21 plus 35, you are getting 56 in the next level. So what is this? So what is it all about? What is this triangle is about? So in the earlier lectures I have just proved a theorem regarding the binomial theorem, which is actually we are expanding x plus y raised to n, right. So we have seen a formula for that also, which is involving binomial coefficients. So this Pascal triangles is nothing but binomial coefficients when we compute x plus y raised to n. So for example, you can see that I will be using this particular x plus y raised to 1, right. So that is x plus y raised to 1, right. Then what is expansion? 1x plus 1y, right. So in the second level you get that, you write that coefficient. Now for x plus y raised to 2, x plus y square is, we know that formula very much. So x square plus 2x plus 2xy plus y square, and look at the coefficients 1, 2, 1, right. Similarly x plus y cube, which is x cube plus 3x square y plus 3xy square plus 1y cube, look at the coefficients 1, 3, 3, 1. So to get x raised to 4, the coefficients can be found from the level 3, because you just add this thing. So this is the idea. So how the first one is 1? Because x plus y raised to 0 is 1, so you just write it. So what is actually tells you that you raise to the power about this level, then you get the binomial coefficients in that. For example, what do you mean by 13 here, and what is the row here? Actually, by the formula you can find this x plus y raised to 13 is equal to summation k goes from 0 to 13, 13 ck x raised to k y raised to 13 minus k. What about these guys 13 ck? So that is actually arranged in this manner, because this 13 c0, this one is 13 c1 which is 13, this is 78 is 13 c2, and like that 1287 is 13 c5, this is 13 c12, and this is nothing but 13 c13, right. So these are binomial coefficients, and if you have the Pascal's triangle, and it will be very easy for you to compute for a larger number, because if from each previous level you get the next one. So what I really want to prove in this, I want to give a combinatorial argument how this thing works. When you add the consecutive number, what is how do you get this 21 in the next level? So let's look at how to frame this formula, right. So if you look at 6 and 15, what is 6? 6 is 6c2, 6c1, right, plus not 6C2, this is 6C0, this is 6C1, and next one is 6C2. So if you add these two guys, what you are getting is 7C2, right? 7C2, right? So yeah, 7C0, 1, 2. So that's true, right? Now let's look at something, some other consecutive number, 28 and 8. So it in which level? It is in the 8th level. So you get, when you add, you get 36. So that means the formula goes like that. It is 28C7 plus 28C, so it's 6, right? I mean, sorry, it is 8C2, I am really sorry. So it is 8C6 plus 8C7, which is equal to, in the next level, which is 9C. So this is 9C9, so this is 9C8, so this is 9C7, right? So this is the formula goes. So you can observe some pattern. If you give 7 is equal to some n, then you can write this like this: 7C2 equal to 7 minus 1 2 plus 7 minus 1 2 minus 1. So I will get a general formula. I will just frame it a general formula, general identity, which is NCK equal to n minus 1 CK plus n minus 1 K minus 1, right? So that's actually you are getting. So whenever you have two quantity, you get the next level 755, right? So this formula is actually works in that. So in this case n will be 12, right? You can check that. So this is the formula we are going to prove using a combinatorial argument. So you may have proof with identities. I mean, you can prove algebraically or use your manipulations of that identity, but I want to do combinatorial proofs. I mean, some argument which gives you the idea. So you know that, so NCK is actually the number of k element subsets of box n or of the set 1 to n. So that is choosing k elements, the number of ways to choose k elements from, so or number of k element subsets of 1 to n. So I just want to count this in a particular way, that is the only thing. So what I am going to do is, first I want to list this number, just writing it in a symbol order, like, so maybe I will just go for an example of counting this idea for something like that. So let me do it like for 5 numbers. I want to calculate something like 5C3, right? Let us try it in a different way. How many ways we can do this? I am doing in a different. So what I am going to do is, I want to make this 5 as a special number, right? Then I make a split. So I want to make 5C3. So what I am going to do is, I find all 3 element subsets from this first part. So how many of that? So that is 1, 2, 3, one of them. Then I can do 1, 2, 4. Then I can do 2, 3, 4 because it can be done. And am I done with it? Because 1 2 3 1 2 4 2 3 4 and 1 3 4 we can be done, right? 1 3 4 right. So I think we are done with that many elements, right? Okay, so I counted it. Now what I want to do is I want to select a 3 element subset from here, and I want to, so I select a 3 element subsets all and add 5 to it, right? And what happens is I have 3 element subset. I'm going to look at 2 element subset, then only I am counting the 3 element subset finally, right? So I select 2 element subset, all 2 element subset, then I add 5 to it. So 1 2 I select and I add 5, so I got a 3 element subset. Then I find 1 3 and I add 5, then I add 1 4, add 5, similarly 2 3 and I add 5, and also 3 4 and I add 5. And what about the next one? 2 1 5 is there, yeah, 2 3 4, I mean 2 4 5 is not that, so I add 2 4, then I add 5. So I select all 2 element subset and I add 5, right? Then I got a 3 element subset, right? So am I left anything? So 1 2 1 3 1 4 2 3 2 4 3 4 yeah. So I think I am done with it. So these are the, so now if you look at these are the only 3 element subsets that I can choose, right? And if you sum it, how many? So this total is 4 of them are there, and this total is 3 and 3 or 6. So you have actually 11, right? I don't know whether we get 11. I mean 10, right? 6 plus 4 is 10. So total I got 10. 10 what I can say 3 element subsets from 5. So now we calculate 5C3. 5C3 is very simple. You calculate back by 3 and divide it 1 2 3. So what you are getting is your 3 is cancelled, your 2 is like that, or you get 10. So you get 10. So this example actually proves all the idea. So what I have done is, now I am going to do is in a more general way, 1 2 up to n minus 1 and n. So what I am going to do is I make n as a special fellow, then I count the nck in different way. So I first choose k elements from here. So I get n minus 1. So how many way to select k element from n minus 1? So that is n minus 1 ck. So a k element subset. So many I got. Next I want to do is I choose k minus 1 elements from n minus 1. Then I add n. But what I am actually doing is I select all k minus 1 elements from n minus 1 and I just add 5 to every element. So that is just an extra thing that you do, but right. But what is that number? But the number of such so if you avoid this, what you are getting? If you avoid this 5, what you are getting? Just 2 element subsets from a 4 element set, but you are adding 5 in order to get the 3 elements. So, same thing happens. That means what? You add first n minus 1 ck, then add n minus 1 k minus 1, right. So, what you are actually getting? You are getting the total number of k element subsets from n. So, I think you understood this idea. So, the second part is a little tricky, because what you are just doing is you already select, in the first part you select k elements from n minus 1, then you got so much k element subsets. In the next case you select k minus 1 elements from n minus 1, right, and you adjoin n to that, because you are only avoiding n, you making a special element. So, if you add n to it, what makes you? You have k minus 1 plus 1 elements, that is now it is k element subset. So, both of them if you are doing, then you get nck, right. So, this adjoining has no effect in the count. So, because whatever the number you n minus 1 k minus 1 you are getting, you are adding n to everyone. So, that many counts are again added to k element subsets. So, this is a combinatorial argument of the identity which actually builds Pascal triangle. I think you understood better. Thank you.